There it is. Angle relationships and transversals. Write this down as the definition of a transversal. A transversal is a line that intersects two other lines. A transversal is a line that intersects two other lines. So in me drawing right here, this is the transversal right there. That one is the one that intersects two different lines. And there's a lot to talk about here, and we have to define it here. The next thing we're going to talk about is interior and exterior. Okay. Let's see if we can do this. Let's go bigger. Actually, we're going to write a little phrase down here. Jot down this little phrase. If two parallel lines are cut by a transversal, write that down in quotation marks. If two parallel lines are cut by a transversal, then, because I'm not going to keep repeating that or writing that, that's the phrase right there that we are going to enjoy. Actually, say that out loud for me. If two parallel lines are cut by a transversal. If two parallel lines are cut by a transversal, then. If two parallel lines are cut by a transversal, then. Go ahead. Put an interior and exterior point. Oh, okay, we gotta do this. If two parallel lines are cut by a transversal, write this down, corresponding angles. Why does this keep writing so? We got to define this first. This is what a corresponding angle is. Think if you could what would I say? If you could reach in and pull up one intersection and put it on top of the other, comma, the angles that are on top of each other are corresponding. Which makes no sense to you. But once I explain it to you, Lucy, you'll understand. Okay? Corresponding angles mean this. I've got two intersections here, this one and this one, right? Yeah. By the way, this is only, all this applies only when you have two parallel lines cut by a transversal. Okay? If you were to take this intersection, pull it off the paper, set it on top of this one, corresponding angles are the ones that are on top and bottom of each other. In other words, angle 5, if I pulled angle 5 up that intersection, put it on top of that one. Which one would, what angle would angle 5 be over top of? Angle 1. Angle 6 would be over top of angle 2, angle 7 would be over top of 3, and angle 8 would be over top of 4. Well, the deal is this, here we go, we're going to say this. If
two parallel lines are cut by a transversal,
then, here's what you write down, corresponding angles are equal. Corresponding angles are equal. With that being said, that would mean angle 5 has to equal what other angle? What angle corresponds with 5? Angle 1. Angle 6 would have to equal angle, Tyler? 2. By the way, this is geometry. If you enjoy this or get excited about it, you probably do well in geometry. If you're not so happy, well. Angle 7 corresponds to angle 3, and angle 4 corresponds to angle 8. And those are all equal. That means if angle 6 happened to be 50 degrees, then so would angle 2. Okay? So there's one. We've got corresponding angles. Unfortunately, I'm going to run out of room, so I'm going to take Mr. Corresponding Angles. I am going to see if I can't either slide him or move him somewhere else. Hold on. That was not what I wanted to do. Let's try to see that. You guys are making smaller. Look, kind of got somebody else in the way. Still got somebody in the way. Yes.
it's okay.
That's all right, it'll be fine. Move. Good. Except for the G. But I could probably move the G file. Okay, so we've got corresponding angles. Now we have what things are called alternate interior angles. Alternate interior angles. That means this, okay? Interior, boys and girls, interior is what I have shaded in green, the inside, in between the two parallel lines. Those are the interior angles. Okay, so there are 4 interior angles that fall within the green line. They are angle 3, 4, 5, and 6. Got it? The lines that are outside of the parallel lines, those bad boys are called exterior angles. Yeah, I'm running out of places. And I have 4 exterior angles, which are 1, 2, 7, and 8. 4 interior, 4 exterior, outside. Okay? Now, alternate interior angles. Okay, what does it mean to alternate?
Switch around.
To flip back and forth. And by alternate interior angles, what they mean? Angle 6 is an alternate interior angle with the angle that's on the other one, but on the other side as well. Angle 6 and angle 3, angle 6 and angle 3 are alternate interior angles. Okay, they're on the opposite side of the transversal and they're on the other side of, well, whatever, the opposite on the other line. Okay, and guess what's going to be true about alternate interior angles? They, well, do we have to say it? If 2 parallel lines are cut by a transversal, then alternate interior angles are equal as well. Okay, that means angle 6 has to equal angle 3, they're both 50 degrees, and angle 5 would have to equal angle 4. Those are alternate interior angles. Angle 6 and angle 3, angle 4 and angle 5. And I'm going to guess, you probably can guess then, what is going to be alternate exterior angles. Alternate exterior angles are the same thing except on the outside. Angle 8 is an alternate exterior angle with angle 1. It's on the other line and on the other side. Like that. You could say it like other line diagonal, alternate exterior. So angle 8 and angle 1 are alternate exterior. Angle 7 and angle 2 are alternate exterior angles. And guess what? If two parallel lines are cut by a transversal, then alternate exterior angles are equal. They are also equal. That means if angle 2 is 50 degrees, what other angle has to also be 50 degrees? What's the other alternate exterior angle with angle number 2? Right?
Angle number 7.
Angle 7 has to be 50 degrees. By the way, you can tell me the other angles. What does angle 8 have to be? If these two angles form a straight line, wait, does that come up in here? No, corresponding alternate. How many angles are in how many degrees are in a straight line? 180. So if this is 50 degrees here, angle 8 has to be 130. And if angle 8 is 130, then angle 1 has to be because of alternate exterior angles. Alright? If angle 8 is 130 degrees, angle 4 has to be. Why? See, this is what geometry is. Why does in geometry you have to prove why you can say something. You just can't pull it out of thin air. Why does angle 4 have to be 130 degrees? Evelyn?
Because angle 3 is 50 and it's an 180 degree line.
Yes, but I didn't tell you that here. I want you to use something that we've already talked about. You could say because they're supplementary, but that's not, I didn't give you that definition yet. So I don't want that one. I want a different reason. Why does angle 4 have to be 130 degrees? Look at all the stuff we've talked about. Why does angle 30 have to be, or angle 4 have to be 130 degrees? Wait.
It's a corresponding.
That's all you have to say is corresponding angles. Because angle 8, if you pull it off, put it back on angle 4, it's a corresponding angle, so that has to be 130 degrees. Why does angle 5 have to be? Why does angle 5 have to be 130 degrees? Because
It's corresponding alternate interior.
what's that?
Alternate interior.
Yeah, alternate interior angles. Or also it's corresponding. There's two reasons. You could say it corresponds to angle 1, or it's an alternate interior angle to angle 5. And that's what geometry does. They give you all these things that are proven, and you can't just say something. You have to say, well, that's because of corresponding angles, that's because of alternate interior angles, or that's because of alternate exterior angles. So you've got all those different things that you're going to, whatever they are. All right, so with that being said, take a look at page 505. And you look really smart when you write it all down.